In this video, let's do several examples of application of normal distribution. And let's do first type 1 problem. When it's given one value, we are going to find probability to the left or to the right, or probability between. Remember, the concept of probability, proportion of the population are interchangeable. The IQ score can be modeled by a normal distribution with mean 100 and standard deviation 15. Then the distribution is normally distributed, the mean is 100 and the standard deviation is 15. It means that this value should be 145, and 3 standard deviation to the left, this value should be 55. An individual whose IQ score is 120, where is located in this distribution? How many standard deviation is located? Let's find. This is 115 and this is 130. 120 should be located approximately here. Then how many standard deviation is this value located from the mean? Let's use the formula for the C-score, and the formula for the C-score is given by the value, which is 120 minus the mean, which is 100, divided by the standard deviation. Then this value 120 is located 1.33. 1.33 standard deviation is here, approximately 1.33 positive standard deviation to the right, and 1.20 is located approximately here, is 1.33 standard deviation to the right. The standard normal distribution, remember, work with Z-score in this and this row, and inside probability to the left. Then we can find the probability to the left, so the probability that one person have an IQ score is smaller than 120, or the proportion of people that have an IQ is smaller than 120 is given in this table. How? Let's go to the table. C-score 1.33, 1.3, and the second decimal is located in this row. We have second decimal. Here we have the first, the score, and with the first decimal, this number is the percentile, percentage below. And if we want to obtain percentage above this value, we need to subtract this value from 1. That is the scale that we use to organize all IQ score. Then most of the people have an IQ close to 100, because all people, for example, here we have all people that have exactly this IQ, could be 90 or 90 something. 100, all people that have IQ 100 are located here, stuck here. Then the percentage of people that have an IQ less than 120 will be this percentage. Approximately 91% of all people have an IQ below the 120. And the complement, which is 9%, 9.2%, all of these people have an IQ above 120. Okay, then let's do another example. In this example, we want to find the area under the standard normal curve to the left of 0.38. Then this value is located 0.38 standard deviation to the left of the mean. Then any value in any normal distribution located 0.38 to the left of the mean, the area to the left is given by this percentage, negative 0.38. This area is the probability to the left. We can use a StatCrunch to solve this problem. But remember, you need to do this problem using table. You can use technology. You are free to use technology even during the test, but you should pretend that you don't use technology. You must use formulas and table, and you need to do step by step all problems. In StatCrunch, the standard normal distribution, when you go to calculator, you have to go in StatCrunch to calculator, and in calculator you have to go to stat. In the bar menu, you have to go to stat. Then in stat, you have to go to calculator. Then when you click calculator, you will have the list of all distribution, the most important distribution, and here could be the normal distribution. When you click normal, then appear this. For the standard normal distribution, the mean is 0 and the standard deviation is 1. Remember that, 0 and 1. The mean is 0 and the standard deviation is 1 for the standard normal distribution. One value located negative 0.38 to the left, then we need to input negative 0.38 in this box. But because we want probability to the left, we need to select this symbol in this box. And when we click compute, we will obtain the probability to the left. That is the same value that we obtained on the table, 0.3520. 0.3520 is exactly the same value using technology. Also, you can use Excel to find this value using technology, or you can use TI-83, or you can use SPSS, or you can use Minitab, whatever statistical software. Then let's do another example. In this example, we want to find area under the normal curve. Remember, area, probability, and proportion are interchangeable. The area under the normal curve to the right of one value, in this case, 1.25. Area to the right, probability to the right. In the table, we need to find this z-score 1.25, and in the intersection on this row and this column, we have this number. This number in this table, remember, represent probability to the left. If the problem is asking for probability to the right, then we need to find the complement. The complement of this is 1 minus this number. 1 minus this number is 11%. 11% of the population have a z-score above 1.25, and 89% of the population have a z-score below than 1.25. We can use technology to obtain this very easy. You can do it in two ways. You can do it directly, or you can do it using pretending that you use table. How? Let's do that. If you pretend that you are using table, you can use this one. You can use this one. Then the standard normal distribution means 0 and standard deviation 1. You need to input here, because table give you less than, you need to use select less than and 1.25. Less than 1.25. And after that, click compute, and you will obtain this value given in the table, 89%. But if you want to obtain this value directly in StatCrunch, then the only thing that you have to do is to select here instead less than, greater than, and you click compute, and you will obtain the exact answer, 11%. This area is 11%, and this other area is the complement, 89%. Another problem. Let's find the area between. Find the area under the standard normal curve between negative 1.02 and 2.94. It's very easy. Then first of all, let's find this z-score in the table. In the table, we need to find the area to the left of this value and the area to the left of this value. And the 2.94 is located here. 2 standard deviation to the right. And negative 1.02 is located here. Negative 1.02 is located here. Then we need to find the area to the left of this point and the area to the left of this other point. And the difference between these two areas should be the area in the middle. In the table, let's find first the area to the left of this number, 2.94. The area to the left is 99.84. And the area to the left of this value must be found in the negative z-score table. And we need to find negative 1.0 in this column and the second decimal in this row. And in this intersection, we find probability to the left of this z-score, this probability. Let's erase that. This is the z-score table, the traditional z-score table. All of these numbers represent probability to the left or area to the left. Then the area to the left of 2.94, 2.9 is here, the second decimal 4 is here. Then in the intersection we have 0.9984, and this is the negative z-score table. And this table also, all number in the main body of the table represent probability to the left or percentile. Then the probability to the left or area to the left of negative 1.0, negative 1.0 is here, and 2, the second decimal is here. In this intersection,
the area to the left is 0.1539.
Then the area in the middle should be the difference of these two areas. It's exactly 0.84. That is the area between negative 1.02 and 2.94. That is equivalent to state the proportion of the population that have a C-score between negative 0.02 and 2.94. This proportion is 84% of the population have a C-score between that. And the probability to select one value between these two C-scores is 84%. All of these concepts are interchangeable.
This is McClave table. McClave used only one table because the normal distribution is symmetric. Then McClave deal only with positive C-score table. The C-score 2.94, 2.9 is here and 94 is here. Then in this intersection we have 0.4984. 0.4984 represent this area, 0.4984. If we want the area between negative 1.02 and 2.94, we need to add the area between negative 1.02 and 0 and the area between 0 and 2.94. And the area between negative 1.02 and 0 is equivalent to the area between 0 and the positive 1.02. 1.02 is located here. Then this area is 0.3461. This area is equivalent to this other area. If we sum these two areas, we obtain 0.8445, which is the same result that we obtained using the two traditional C-score tables.
You can do this very easy in StatCrunch. How? Then to work with StatCrunch, you can go to Stat, Calculator, select Normal Distribution. Then, because we are dealing with Z-scores, we select mean 0 and standard deviation 1, and we select between because it's given two values. Between. When we select between, appear then two boxes here. In one box, we are going to input negative 1.02. In the other box, 2.94, and we click compute the probability 84. That is using technology. You must pretend that you don't use that. You must use formulas and table.